Well, hello and welcome back to my workbench. It is time once again to try to fix something, and today on the workbench I am looking at another dead PS5. I believe this is a no power, and we're about to find out just how no power it is. So let's start off. I've got the cord in the back of it. I think, yes, it's connected to something anyway. Let's give it some voltage and see if we can tell if that power supply is starting or not. Yes, I would say that power supply is starting. That's step one. Do we beep? We don't beep for eject. Do we beep for power? Oh, we did finally beep, but no light. Okay, are we beeping every time? No. Ever so often we beep. No light whatsoever. And we don't, oh, we are beeping on eject now. Maybe I tried to turn it on or make it go too soon, I don't know. So we're beeping, so we have some signs of life where we are not totally dead. So is that technically really a no power if it makes noise? Let's get some covers off. And with the side plate off, we can see this unit is still factory sealed, which is always a really nice thing to see. That's very nice. Okay, let's get a little further into it. We might as well get on down to that main board because that's where we're going to have to end up being. Well, I have gone straight for removing the circuit board, so I've got it out on the bench, and I'd like to take a look at the current draw. So I've got my leads connected, and I'll take a quick check of what it does when I give it 12 volts. Just a quick check. It's on channel 1, and power. That's really low, 82 milliamps, and hanging. And then going down, so it gives up. So that does not ring a bell, man. I have to think about that. Is that a short somewhere possibly? We'll try it again, but I don't immediately off the top of my head recall that one. 82 milliamps. Okay, I don't think it's going to be a 5 volt short because it wouldn't hardly do anything. And then it hung at 26 down to 10. Okay. So yeah, that's a sick board. Let me get set up. We'll look around the board, see if we can find some shorts or anything obvious. Or maybe we'll just look to see if we have our proper voltages around here, the 3.3, 1.8, 1.15, that kind of a thing. But, that's an odd one. All right, let's take a quick look around at this board, see if we can find something, anything that's out of order. Let's see where to start. Maybe just start in continuity mode. See if there's any obvious shorts around our DC-DC converter here. This looks to be the dialogue chip. I think I can barely make that out. Yep. Okay, we're in continuity mode. This is the 3.3. Doesn't look bad at all. This is, I think this is like 1.15 over here. Nothing there. Some of these other capacitors around this chip. No. Little tiny capacitor right here, which I know goes to the south bridge. No. No short. Let's glance around the south bridge. On some of these filters going in. Nothing, nothing, nothing. One of these has battery voltage on it, so it'll beep. Hitting a few capacitors there. Nothing. Nothing is jumping out. Alright, well, I have been looking around this board for a little while, and I haven't really found anything. I looked around the DA9065 chip here, and all the voltages seem to be there. No shorts. Let's see, I looked around the HDMI encoder. I see there's no shorts. Around the Wi-Fi Bluetooth module, no problems there. Around the SSD controller, all those voltages are coming up. So everything looks pretty good, except it just doesn't work. And so now our options are going to be kind of, do we have maybe a bad south bridge? Which, this is a 69GG, which is not good. I would need to substitute a 61 in there. Could we have corrupted NOR contents? That's a possibility. I'm leaning toward a bad SSD controller because of how low the current draw is. And that's just a guess, though. So instead of guessing, I'm going to go ahead and connect the wires for the UART, and let's just see if there's any error codes present, and maybe something that'll point us in a little more definitive direction. Well, I have connected the UART there, and I've read the last 10 codes, and there they are. And you can see they look to be all SSD related. It's actually two different codes just repeated over and over again. So I'm going to say we have a bad SSD controller. That's a good place to start anyway, because I did check. Those voltages are coming up. All the voltages related to the SSD, the 0.8, 1.2, 2.5, those are all coming up. So kind of points toward a bad SSD controller. And that's where we shall start. Alright then, our SSD controller has been replaced, and hopefully works better than the last one. Let's see. My leads are connected. We're ready to give this board 12 volts and see if it does what it's supposed to do. Let's see. No, 82 milliamps. Just like before. Yep. And then it eventually does settle back down, I think, to 10 or so, yeah. So no, we have changed our SSD controller for naught. So, what else is it? Is it the RAM I see here? I don't know. That may be my next stop, though. Alright, so replacing the SSD controller did nothing for us. I went back and reread that error message again and noticed that it said, make sure that the voltages were coming out of the SSD, the DA9081, RT5127, but then it also says check F7001, which is right in there, if you can see it, F7001. And if you will join me under the microscope, F7001, I'm in continuity mode, as you can hear. F7001 is wide open. So, yeah. Do we happen to have a short? Oh, we do. We have a short right here. F7001 is shorted. So, there's our problem. Okay, let's figure out what's shorted. I'm not quite sure where that connects to. I believe that's a 5-volt line there, but I'm not 100% sure on that one. But wherever it goes, it is now shorted. Let's find it. All right, I think I'm finally ready to inject. I had to charge up my infrared camera and the phone I use it with. So while I was waiting, I did hunt around to see if I could figure out where this F7001, where it fed, what part of the board. It is a 5-volt circuit, I figured out, and it seems to land over in this area. I found it on a couple of places. I found it, I think, right in here. If I can get that to focus. Right in, where was it? Right in there. Also up in here somewhere on this chip. So it goes to several places over there. So maybe we can narrow it down. I've got my second channel of my supply set for 2 volts at 2 amps, which I'm hoping, this seems to be a pretty dead short, so that should be more than enough heat developed to find something. I hope. Let me get my infrared camera going here. Okay. Let's see if I give it some juice, what gets hot here. Anything? I'm seeing some reflections, I'm afraid. Turn it back on. We're getting 2 amps of current there. It's such a dead short, though. It's only 0.4 watts. Just seeing lots of reflections. I expected to see something in this area, but I'm not seeing it. Here's where I'm injecting, right over here. I can definitely raise the voltage. Get a little more current through there. Just kind of thought that would be enough to jump out at us. But it is not to be. We can look on the other side of the board. Anything over here? Maybe. Maybe. Right in there. Oop, my finger out of the way. Where'd it go? There's several shiny places. What's this right here? All right, let's look in that area right in there. Let me turn off the power, turn off the voltage. See if we see a change, like a cool down or something. No. Okay. Let's give it some more current. Three amps. Actually, 2.5 amps at the moment. That is 1 watt of power dissipation. Is it right in there? It's got to be. Yeah. It's got to be it. Turn it off. Let's see if that cools down. Oh yeah, it cooled down a lot. What is that? This chip. Is it a capacitor right in there? Let me turn it back on so I can narrow it down. Right in there. There are 2 large capacitors right there. 2 large capacitors side by side. All right, maybe we can narrow that down with some alcohol. Let's take a look under the microscope and see if we can narrow this down a little further. Let's get a little alcohol on a cotton swab. Now, these 2 large capacitors you see here are what was, that's the area. So let's put a little alcohol on here. Turn it off. Turn on the 2 volts. Didn't heat up as much as I thought it would. Make sure it's not this IC right here. I really think it's the capacitors. Let's just see though. Yeah. Doesn't seem to be that chip. I don't think it's this chip. We'll double check it though. I'm thinking that bottom capacitor. Although it looks physically fine. Looks physically fine, but I don't think it is. Let me just kind of confirm here with the meter. In continuity mode, we do have a short right here. We do indeed. Less than 1/10 of an ohm. So that's one problem, is we're not getting a whole lot of heat because, you know, less than 1/10 of an ohm resistance isn't going to give you a lot of heat. It's a very short circuit. But I think we got enough heat to know it is that capacitor. Let's find out. Let's find out. Add a little leaded solder to it. That is a large capacitor. As far as ceramic surface mounts go. Park it right there a second. And do we have a short right here? We do. Well, you get in continuity mode. I was in resistance mode, so there was no beep. Yes. And we're all clear here. Yep. So, shorted ceramic capacitor. And let me find a donor. Where we can pull that from. Well, our capacitor has been replaced right over there. If you can see, it's this upper one right here. That's been replaced. And the fuse has been replaced. F7001, that's a 5 amp fuse. I replaced that. I didn't have another donor board identical to this one. I was using an earlier, like a EDM 10 or 20 donor board. So I actually lifted the other capacitor one right beside it, because it's going to be identical to it. And I checked the value of it, and it seemed like it's going to be a 47 microfarad. So what I did was I looked at another board for a similarly sized capacitor in that same area. I think it's in that same circuit actually. And I pulled a board. I lifted that off a donor and measured, make sure it was 47 microfarad, and it was. So I think we're good there. We've got two good 47 microfarad capacitors there. We've got a fresh fuse. Let's see how much current this thing draws now. I got my supply set up over here, 12 volts. We're using this left channel. Turn it on. There we are, 330 milliamps, then come back down. All right, finally, I think we have a working board. Let me slip this back into the chassis. Let's just see, just to see how good and working it is. Well, I have slipped it back together just enough to test. I don't want to be overly confident. I haven't just put a few screws in it just to hold it together. Let's see if she will turn on. There we go. Blue light, fan spin. Do we have a picture? Yes, we do. Excellent, excellent. All right. I think she's going to be all right. Let me put it back together. There's not really any cleanup to be done. This thing is really clean. I need to check the Blu-ray and that kind of stuff. Let me do that, and I'll bring you back with a final checkout. How's that sound? Well, this PS5 is fully reassembled and seems to be doing just fine. No other problems. Wi-Fi works. It's loading a game off the Blu-ray drive. Everything works. And right there, if you can see it, is the capacitor that took it down. If I can get it to focus. Maybe not. Well, that was the capacitor that shorted and took it out. So anyway, if you like that one, thought it was somewhat interesting, educational, entertaining, any of the above, if you did, please give me a thumbs up. And I'll see you in that very next repair. So long for now.